Alright guys, welcome to this video. Today I'm going to be talking about stoichiometry. So stoichiometry is chemistry's dimensional analysis. It's the biggest fundamental, in my opinion, of chemistry because it basically is the language of all the reactions. If you have a certain amount of moles, right, you know, in a reaction, you know how much of the products you can make. So that's really powerful. It's a powerful thing about stoichiometry. So what I have written already here is the highway of stoichiometry. This is the overall picture of how you want to go about this. So you're given something, you're given a mass, you're given an amount of moles of a product or a reactant, or a substance, basically. And you want to convert it. The first step is to convert it to moles. And then you want to apply any mole ratio from the reactants to the products, or even between the reactants, or even vice versa, with the products and the reactants, if you want to see how much of a reactant you need to make a certain amount of product. And then, you might have to do some unit conversions if you have moles. You usually do have moles, right, at the end because you're with the mole ratio. And if you want to turn that into grams or kilograms or even liters, if you're doing some gas stuff, you're gonna have to use that. And then that's how you get to the end. So it's really not that bad once you think about it. And the biggest thing that you want to do, or we want to keep in mind, the golden rule of stoichiometry, I'll put it right here. The golden rule, cancel units. That's really all you want to do. If you cancel units, then you're on the right track. And the best way for me to know how to cancel units. I know a lot of people they get tripped up on should I flip the mole ratio. But say you have moles right here, right? You're starting with moles. I put a one. I make it a fraction. I put a one under it, and then I have my ratio. Now, molar masses are in grams per mole. So you want to make whatever this is, you want to put that on the bottom of the second one, or whatever you're multiplying it by, so that you can easily cancel them out. Because this is division, right? This is division. Moles divided by moles is 1, and then you're left with grams. Let's say you have grams instead of moles. And you want moles. Well, you do the same thing. You flip the ratio so that grams is on the bottom, so you can easily cancel this out. That's how you can do this with anything, right? You have moles of oxygen gas, and you know that 2 moles of oxygen gas is in whatever reaction to produce 1 mole of X. Now you cross these two out, and I guess you can have like 5, and now you have 2.5 moles of X. It's that simple. That's the most powerful part of stoichiometry. It's the it's really all there is, cancel units and flipping around to make sure that you can cancel out the units. And everything after that is just. Can you distinguish between which conversions you want to use? There are many different types of them. There's Avogadro's number, which tells you how many particles of a substance exist within 1 mole of that substance. There's the ideal gas conversion, which tells you how much volume 1 mole of an ideal gas takes. There's stuff like how many moles of a certain element takes up 1 mole of a mineral. That's all stuff you need to use, but you can easily figure out how to use it if you think about canceling units. All right, so let's do a problem now. So this problem asks for the number of moles and mass in grams of ethene required to react with water to produce 9.55 grams of ethanol. So the first thing you want to do is to write down the full chemical equation and balance it, because balancing is really important. That's how you get the correct mole ratios. So you have ethene reacts with water and yields ethanol. And after that, we're done because there's two carbons and there's six hydrogens on both sides and there's one oxygen on both sides. So we've successfully balanced the equation just by writing it out. So the mole to mole ratio in this equation is 1 to 1 to 1, which is really lucky for us, but most of the time it's not going to be that. And balancing properly will give us the correct mole ratio. So another thing that's important to recognize is that this question is only asking for ethene, and it tells us that it just reacts with water, so that means that it's in excess. We have an infinite amount of it. What's cool here is that we're using the products to find stuff about the reactants, so we're kind of going backwards. So next, we want to find the molar masses. So let's do ethanol first. Ethanol, we have two carbons, so 2 times 12 to 12.011 plus 6 times 1.008, that's hydrogen, and then plus 16, and that's going to give us 46.07. So I'm just going to write it down there, 46.07 grams per mole of ethanol. And we use a big M, not to be confused with molarity, to denote molar mass. So next, let's do ethene. So ethene, we have two carbons, so again, 2 times 12.011, and four hydrogens, so plus 4 times 1.008, which will give us a small number, 28.054. And now we can go and write 28.054 grams per mole of ethene. And I was messing around with the sig figs here, but in my opinion, it's best to use all that are given to you. So now let's do the actual math. We have 9.55 grams of ethanol. I put it over 1. Now, there's another method that people like to use. It's called the train track method, where instead of putting it all over 1, they just do this. Or they do a big line and then they do that. And that's also pretty cool to be organized. I've drawn it now, so I'll do it. But it's the same thing basically as just the fractions. So you put the 1 there and then you want to multiply everything. So, or multiply across. So our molar mass is 46.07 grams per 1 mole of ethanol. Same thing, right? So grams, grams. And this cancels out. So let me do some math. 9.55 divided by 46.07 is 0.207. But we don't need to do that right now because we can just go all the way across. So now 1 mole of ethanol reacts exactly with 1 mole of ethene. And now this is asking for the mole and the mass of ethene. So whatever we get here, so I mean, because we already got 0.207 times 1, we already know that this is going to be 0.207 moles of C2H4. But because the molar masses are different, we have to utilize ethene's. Oh man, I'll just use the big number. Ethene's molar mass. Oh boy. See, that's where I went wrong. See, guys, this is how you know easily if you made a mistake because the the units didn't cancel out. Grams don't work with moles. 1 mole C2H4, and now you can go. This is the best part. And now you just go straight across and divide where you need to. Um, so 0.207 moles of ethene times 28.054 is equal to 5.82 grams of caffeine. So as you see, this is a super simple and easy way to do stoichiometry. It's not meant to be hard. Just remember the golden rule to cancel units.
Thank you for watching. I hope to see you next time.